Hello guys, today I would like to talk about the web application basic attacks for security professionals and the WASP top 10 as in the week 1, but here there will be the basic information about the web applications, especially HTTP protocol. I suppose everyone should know and they should understand how it works. Sometimes it seems that the whole world revolves around HTTP and its variants. Much of what we like to do on the web somehow uses HTTP. For that reason, it's probably the networking protocol that is most used by threat actors. It's important that we truly understand how the protocol works and the vulnerabilities that it can create. The HTTP protocol, let's look at a few facts and the definition before we proceed to details about HTTP. The HTTP 1.1 protocol is defined in RFC 7230-7235. In the examples in this model, when we refer to the HTTP server, we basically mean a web server. When we refer to HTTP clients, we're talking about browsers, proxies, API clients, and other custom HTTP client programs. When we refer, HTTP is a very simple protocol, which is both a good thing and a bad thing. In most cases, HTTP is categorized as a stateless protocol that does not rely on a persistent connection for communication logic. An HTTP transaction consists of a single request from a client to a server, followed by a single response from the server back to the client. HTTP is different from stateful protocols such as FTP, SMTP, IMAP, and the POOP. When a protocol is stateful, sequences of related commands are treated as a single interaction. A server must maintain the state of its interaction with the client throughout the transmission of successive commands until the interaction is terminated. A sequence of transmitted and executed commands is often called a session. In this figure, we can see the very simple topology that includes a client, proxy, and the HTTP server, or in other words, web server. HTTP proxies act as both servers and the clients. Proxies make requests to web servers on behalf of other clients. They enable HTTP transfers across firewalls, and they can also provide support for caching of HTTP messages. Proxies can perform other roles in complex environments, including network addressing, translation, and the filtering of HTTP requests. HTTP is an application-level protocol in the TCP/IP protocol suite, and it's used TCP as the underlying transport layer protocol for transmitting messages. HTTP uses a request-response model, which basically means that HTTP client program sends an HTTP request message to a server, and then server returns HTTP response message as demonstrated in this figure. In this example, the Linux TCP dump utility is being used to capture the packets from the client, which uses this IP address, to the web server to access the website HTTP hacker.org fake website. And here we should write sudo TCP dump.net and the IP address of the. And then we can see the some responses, get responses, HTTP, get requests, and the HTTP responses. In this example, you can see that the packets that correspond to the steps shown in this figure, the client and the server first complete the TCP three-way handshake. It's SYN, ACK. Then the client sends the HTTP, this one, HTTP get request, and the server replies with the TCP, ACK, and the other contents in the page with the HTTP 200 ACK response. Each of these request and response messages contains a message header and a message body. An HTTP message, either a request or a response, has a structure that consists of a block of lines comprising the message header, followed by a message body here. the time, IP address, flags, the type, the response code. Here, HTTP request details in this figure. For this case, we use Wireshark, the Wireshark utility. As you see, the HTTP messages are not designed for human consumption and have to be expressive enough to control HTTP servers, browsers, and the proxies. When HTTP servers and the browsers communicate with each other, When HTTP servers and the browsers communicate with each other, they perform interactions based on headers as well as body content. The HTTP request shown in the above figure had the following structure. Let's talk about this example. The method. In this example, the method is an HTTP GET. Also, it could be any of the following. Let's talk about the types of request. GET, it retrieves information from the server. HEAD, basically it's the same as GET, but returns only HTTP headers and no document body. POST sends data to the server, typically using HTML forms, API requests, and so on. TRACE does a message loop back test along the path of the target resource. PUT uploads a representation of the specified URI. Delete deletes the specified resource. Options returns the HTTP methods that the server supports. Connect converts the request connection to a transparent TCP/IP tunnel. The URI and the path to resource fields. This represents the path portion of the requested URL. The request version number field. This specifies the version of HTTP used by the client. The user agent is in this example, Chrome was used to access the website. In the packet capture, you see the following, like this. Several other fields, accept language, accept encoding, and the other fields also appear. The server, after receiving this request, generates a response. Here in this figure, we can see the HTTP response details. The server response includes a 3-digit status code and a brief human readable explanation of the status code. Below that you can see the text data of the HTML code coming back from the server and displaying the website contents. The HTTP status code messages when we could not enter to one website. You can see like error 404 or something like this. It means messages in the 100 range are informational. Messages in the 200 range are related to successful transaction. Messages in the 300 range are related to HTTP redirections. Messages in the 400 range are related to client errors. Messages in the 500 range are related to servers and the errors. Also, I would like to talk about the HTTP URL structure. It's also have some standard. HTTP and the other protocols use URLs, and you are definitely familiar with URLs because you use them every day. This section we will explain every part of the URL for deep understanding. Let's consider that we have this kind of URL. Let's break down this URL into the component parts. The scheme, this is the part of the URL that designates the underlying protocol to be used. It can be HTTP, FTP. It's followed by a colon, this one. In this example, the scheme is HTTP. Host, this is in the IP address, numeric or DNS based for the web server being accessed. It usually follows the colon and the 2 forward slashes. In this case, the host is thread of hacking.org. Port. This optional portion of the URL designates the port number to which the target web server listens. The default port number for HTTP servers is 80, but some configurations are set up to use an alternate port number. In this case, the server is configured to port 8123. Path. This is the path from the